I'm grateful for both Jennifer and Tiller, who are here to talk about Reed's dual engineering program. We know that 3-2 programs are of interest to families because they want to merge liberal arts with an engineering degree, and this is an approach that we offer. And because there's so many questions about it, we have a faculty member and one of our Reed students who's currently at Columbia, and I've asked them to talk a little bit about their experiences.
I'm in the Department of Physics, and my research is in the area of solid state physics. So I study the essentially the electronic properties of a number of different materials. As part of that, I've collaborated and worked with engineers across a range of different fields, from electrical, mechanical materials, chemical engineering, as part of that work. And I teach our intro to electronics class, and our junior lab. So I do a lot of sort of hands-on work in my teaching as well. When students are doing the 3-2 program, they're really not sort of visible to the engineering school until their junior year, when they apply to go there, as to finish out their degrees. And so when they do that in their junior year, I write a nice letter telling about all the great accomplishments, and kind of sort of going through and describing how they've satisfied all the prerequisite requirements. So I'm the person who officially writes those letters. And then I'm sort of the point person who gets information from the schools if they want to update us on, whatever's going on with the program, they would reach out to me.
Excellent. That's great.
So, yeah.
And Tiller, why don't you introduce yourself? Let folks know when you started at Reed, what you majored in, and where you are right now, both in terms of your academic program, but also physically where you are, because it looks kind of cool.
My name's Tiller Van Doren. I started Reed fall of 2021. So I'm a fourth year college student. Um, but over here, since I'm in the 3-2 program, I'm considered a junior still. So right now over here, I'm at Columbia University in Manhattan, New York, and I'm studying mechanical engineering coming from Reed College, where I studied physics.
And so you took advantage of the 3-2 program, and is that a lab you're in right now?
Yeah, so this is a lab I work in. It's kind of like the lab for the mechanical engineering department. I work here as a lab assistant, um, where I get the opportunity to work with and on a bunch of CNC machining equipment.
What is CNC lab equipment?
CNC machines are it's a kind of subtractive manufacturing. So traditionally, where you would have mills or lathes that can very precisely hold parts that you would cut away from in very like precise ways to create parts that can be used for um, more like complicated or high-end designing. CNC is like a computer controlled version of those machines. So it's just you have a piece of metal or a piece of plastic and you want to parts away from it to form a really precisely made part. You'd use some kind of mill or lathe, and for this lab space, all of ours are computer controlled.
I'm kind of curious. You had your 3 years here at Reed, and now you're in your first year at Columbia. What's different about your educational experience? How would you describe what you learned and did at Reed and what you're learning and doing right now?
I would say my experience is night and day. Uh, Reed, I would say, is very Reed had a very like academic and rigorous focus to it. I found that a lot of the times I was taking really deep dives into, I don't want to say complex material because it's material I would learn everywhere else, but learning it in a way that I feel like I gained a much like deeper and rock solid understanding of the concepts around it, especially like in my physics and math classes. And here at Columbia, they teach me the foundational stuff in all my classes. Like they teach me how to CAD, which is like 3D modeling for designing parts for engineering. Uh, they teach me CAD, they teach me various mechanics classes like mechanics of solids, mechanics of fluids, thermodynamics. So I have those like basic classes.
So to me, it sounds like your initial Reed education focused on theory and Columbia is focusing on practice. Is that safe to say?
That's a good way to put it. Um, yeah, Reed really drilled in the theory for me.
So when you think about your initial theoretical training, does that make the practical stuff easier? Do you find yourself, um, how has that helped you understand the concepts that you're getting in this part of your degree?
I think in a way, yes. I'm like I mean there's no replacement for hands-on experience. Um and I think like that is one of the more valuable parts I'm getting out of Columbia. But in terms of like my classes themselves, I feel like been given a really solid framework to not just like look at the equations that the teacher's throwing up on the board and memorizing them, but really like understanding where they come from and like understanding the like bases behind a lot of the assumptions that engineers make to get around the more unsolvable parts of physics. Or I shouldn't say unsolvable, but more difficult to solve parts of physics.
Are you happy you decided to do it as a 3-2 program, pursue engineering as a 3-2 program?
Yeah, overall, yes, I'm really happy I did this. It's been a pretty wonderful experience. I think looking at around at some of the other 3-2 students in my class, I know a lot of them had it a lot easier off getting into the program. I know Reed is uh, can be quite rigorous in the side of math and physics, but at the same time, I feel like that rigor has given me a kind of grit that is really paying off as feels like I'm churning through these classes like nothing. I mean, not nothing. They're definitely something, but it's I feel like I'm not necessarily confronted with the same like depth of problem that I've had to deal with on a daily basis. I read.
Jennifer, why would someone choose to do Reed's 3-2 program instead of perhaps a different path?
Well, I think, every student has to choose their college path based on their own individual goals and personality and, preferences. But what Reed, I think, really offers is a very individualized educational experience where students can come in and work with faculty advisors who are really paying attention to who they are as a person, and really be immersed in a pretty intensive intellectual community. So peers who are also really excited about learning, really excited about ideas, and and then as part of the liberal arts, you're taking classes and you're in conferences, like hashing out ideas across a really wide range of disciplines. So learning to communicate, not just to communicate well to your peers or to people within your own field, but learning to communicate well across disciplines, learning how other disciplines ask and answer questions. Um, and all of that, it builds really important specific skills, like I was talking about communication, but I think also those sorts of diverse experiences build creativity. And that's really critical as well, to success as an engineer. So it's kind of a wide ranging answer. I think there are a lot of reasons one might choose Reed, but those are some of the ones that come to mind for me.
Do you find that students are intentionally trying to take advantage of other pieces of our curriculum, that that's a part of what they were looking for is to be curious about these different areas?
I do. I actually think most of the students that I have worked with have some sort of interesting angle on engineering. So they're they're not just sort of laser focused on becoming, say, a civil engineer, but they want to do it in a context of their broader interests. So they're really interested in art and architecture, or they're really interested in textiles, or they have a passion about um, the environment, or I have a student who's really interested in combining computer engineering and psychology. And so, every person's different, but I do think the students who come to read have um, some have passions about things that can be really interesting and unique, like combining different fields. And honestly, a lot of the important work going on in our world is very interdisciplinary as well. So maybe that sort of mirrors the larger culture in which we're living, and the directions they might go in the future. So I really think it's cool that at Reed they can do that. Even in this sort of constrained 3-2 program, you're still taking about 6 courses outside of the scientific fields, and those can be chosen pretty much according to the student's interests. So plus 2 semesters of Hume as well. So there's definitely an opportunity to build and explore some of those other skills.
And they start applying their junior year for the other program.
They would apply to the 3-2 engineering program in the junior year, in the late winter.
When you think about, you get a student that comes to your office and says, "Hey, I'm thinking about this dual degree program. Tell me about that conversation. What does that sound like?"
Well, I usually would try to get the student talking just about why they were thinking about engineering and why they were thinking about the dual degree program. So really trying to get into what engineering means to the student. I think most people definitely think of engineering as a good career and as a place that you can apply scientific and mathematical knowledge in sort of practical and useful ways. But students have very different ideas of what that might actually mean. Some of them have a really fully formed sense of a particular career they want to do and a reason, like they've had some experiences in high school that really point them in a particular direction, where other people just generally know that they like science and math and want to have a great career. And so it's a really good starting place to just understand where a student is at and sort of what their goals and their passions are, so that we can then start them down a road that's individualized for their own interests. So I want to make sure that if they have an interest in 3-2, we are maintaining them on that pathway, because when you're going to do 3-2, you're essentially, the requirements for the 3-2 program include the prerequisite requirements. Columbia has the most significant prerequisites, so I generally base students' curriculum on satisfying those. And then they have to also complete their group requirements, which actually are also prerequisites for Columbia. And they have to do all the required courses for their major, with the exception of the thesis. So in order to do that in 3 years, you essentially move any elective options out to your senior year. In a sense, you've turned engineering into your elective. And that means that every course you take has to sort of satisfy one of those 3 areas of requirements. So if we want to keep those options open, then from the very beginning of the very first year, it's important that we're paying attention and building the classes into the schedule. And then also, 3-2 isn't always the right thing for every student. And sometimes people realize that after a year, or sometimes it takes a little while. There's a lot of reasons that students change their minds, right? But if they are considering other alternatives, then you certainly need to have an opportunity for them to explore those as well. So, for example, I have a first year student right now who came in really gung ho about 3-2 engineering, and in his second semester is now, I think has decided to pursue neuroscience instead. And so, it's important to continue to have these conversations as people's interests evolve.
So there, you're not making an extreme shift to satisfy someone's path of 3-2.
I'm not making an extreme shift for a particular area of engineering. So when they apply to, for example, Columbia, they will apply to the mechanical engineering program at Columbia or the chemical engineering program at Columbia, or et cetera. And the prerequisite courses for all those areas of engineering are largely identical. So in some areas you might need like one additional class, but there's not a huge difference from one field. So, if you started thinking you want to do mechanical and then you want to switch to civil, or, you're doing computer engineering, but you want to switch to computer science, there's not a tremendous difference.
So Tiller, I saw you sort of nodding your head when Jennifer was talking through kind of the course curriculum. Tell me about what courses you took while you were at Reed when you were carving your path towards, where you are now at Columbia, and how you worked with your advisor with your schedule.
Yeah, you're pretty much taking like the entire physics degree, um, and your 3 years at Reed. If you're going to be doing the 3-2 program, it is going to be 4 classes per semester. And I think like for me from the get-go, I knew that I wanted to do it. And like because of that, I had to organize my schedule that way. And it took a lot of very meticulous planning, um, going back and forth, like with my parents about like how to set up these classes, how to properly go around this. And it was a very tough part of actually going into the program.
I want to emphasize that we do tailor every student's experience to the student. And for some students who may not be prepared or wanting quite that intensive a course load, there are alternatives as well. So, for example, there's two main alternatives. I mean, you have to satisfy all the requirements. I mean, that's non-negotiable. But you can sometimes take a course over during summer, so that can spread things out a little bit. It's also completely fine to do this as a 4-2 program. So if you wanted to sort of spread out the part that needs to be done at Reed over an additional year, it's possible to do that as well. Most people don't want to do that because it just extends the time so much, but that's another alternative. The other thing would be, you can really major in any field at Reed and do 3-2 engineering, because Columbia is just interested that you've done these prerequisite courses. The challenge comes in where if you're majoring in a field that doesn't have any overlap with the prerequisite courses, now you're adding even more to your plate. And so that gets particularly challenging. So physics has good overlap. Math has pretty good overlap. If you're interested in CS or computer engineering, I think the computer science degree works out pretty well. And we've had students do chemistry and chemical engineering. But you need some kind of overlap there if you're going to finish it in 3 years without a lot of summer classes.
Tell me a little bit about, are you having group meetings with students at the beginning? I know that you partner with some other faculty too. Give me a little idea of what our current advising approach is.
Yeah, absolutely. So last year, and I think we'll do the same this year, we did have a meeting during, like before classes started, where students could come talk to me. And I just try to reach out to everyone whose names I get from advisors, or, sometimes they know to reach out to me, or they come to the physics open house and we announce it there. If you're watching this, you can reach out to me. And then I also work with, I have a colleague who's also, so we have like this combined programs committee actually, which consists of me and my colleague Jim Fix in computer science. And so he's great about advising students who are interested in computer science or computer engineering of some of the details of, not just the required classes, but the ones that are going to be really helpful for them to have going into those fields, and also sort of, internship experiences and things like that. So I work with him and sometimes with other faculty in physics as well.
You mentioned that a student could do the 4-2 program. I would imagine that some students might pursue engineering as a master's degree. You have
Yeah.
somebody who says, I'm going to do a 3-2, and then there's some reasons they decide not to for that make a lot of sense. What do you think the most common reason a student might choose to stick around for their senior year?
Oh, yeah, that's a great question. So usually it's because they want to write the thesis. I think one of the great advantages of the Reed education, I was talking before about how it's individualized for each student. There's actually, if you're not cramming everything into 3 years, there's a fair amount of flexibility to take electives in areas you're interested in and to really build towards this thesis experience, which can connect your education at Reed with your passions or your longer term goals, or just allow you to explore something new that you're excited about. And so students are often thinking about that from very early in their time at Reed, and they're excited to do a thesis. And if they do 3-2 program, they are not going to do a thesis. In a sense, the larger projects they're going to do at their engineering institution in some sense substitutes for that experience, but it's not the same. So I would say that's one big reason, and just wanting to graduate with your cohort. You're making friends. You're kind of in a group of people that are working through the classes in your major, and so it's exciting to be able to have graduation with those same people. And then I guess another reason would be depending on sort of what exactly you want to do with your engineering degree. Sometimes it makes sense to just go into a master's degree. And in a similar amount of time, like a master's sometimes can be done in 1 year, it's often 2 years, then you end up with a bachelor's from Reed and a master's degree instead of with 3-2, you get 2 bachelor's degrees.
Jennifer, you sort of mentioned the different ways folks can do engineering, right? We started sort of getting into that. Can you say a little bit more about that?
There's essentially 3 different pathways to engineering, in the sense that a student could do the 3-2 program, so get a bachelor's in some field from Reed plus a bachelor's in engineering from, say, Columbia. They could get their bachelor's at Reed and then go to a master's or even a PhD program in engineering and work as an engineer, or they could work in an engineering field after graduation from Reed. That's probably the most challenging one. I want to talk there's sort of a distinction in what we mean by the word engineer, right? So if we think of engineer as somebody who's applying knowledge, scientific knowledge, to solve practical problems, in some cases, those problems are more so for example, for civil engineering, you're thinking of things like maybe building roads, bridges, buildings. You might think of things like environmental engineering, which are about soils and waters and structures. And those all have really important, they're sort of public facing, right? Like there's often government contracting involved, and it can be important to be licensed as an engineer if you're doing that work. So licensure processes start, typically the education requirement for that is to have a engineering undergraduate degree from an ABET accredited institution. And you get that with the 3-2 program. The licensure is done state by state, so every state has different rules, and there are workarounds. So if you did get, say, a physics degree, for example, from Reed, and then go on and do a master's in engineering, in some states, you could use that as a basis for licensure later. So a lot of students who come to Reed, they're really intellectually curious people. They're really interested in sort of the production of knowledge, which is more on the research side of things. And especially if they're thinking about master's and PhD programs, often they're thinking more in terms of those sort of research type activities. And for those, it's fine, to go on and do a master's and PhD straight from your Reed degree. In terms of getting an engineering job directly from Reed, again, that's not going to be a job that's requiring licensure as an engineer. It's going to be a job where you're using knowledge to solve problems. So these will have different sorts of job titles, maybe working in, say, high tech or biotech or something like that. So you're doing that type of work, but you wouldn't be probably hired if somebody's looking for a licensed mechanical engineer, they wouldn't be hiring you from Reed. So yeah, so we just have to kind of have those conversations and make sure students are clear on the decisions that they're making, and that I understand really what their goals are. I think it's just important to know that there are these possible paths ahead of you, and when the time is right, you can make that decision, and the faculty you're working with at Reed will help you think about what's going to be right for you and what's going to, give you the right foundation for the career that you're going to want.
What programs do we have partnerships with?
We have partnerships with Columbia, Rensselaer, and Caltech. I would say that right now the majority of our students are going to Columbia.
Mm-hmm. So, Tiller, as I understand it, you got accepted to both Rensselaer and to Columbia. What do you like about the program?
I really like having the strong foundational physics and math, like theoretical background. I feel like anytime I see something like pop up in my like engineering classes nowadays that should look like big new scary equation, like I I can see it for what it is. I can see um like a lot of engineering is making the assumptions to get out of solving um large uh partial differential equations. It's like making assumptions to make those equations easily solvable. But I come from a place where I was expected to grapple with taking more complex uh analytical processes of like actually deconstructing these equations and solving them like analytically, and then also like when analytical solutions aren't necessarily possible, finding ways to solve them accurately through computational methods. I think Reed really set me up to like kind of have that sort of groundwork, but then also like I feel like at Columbia I'm getting an opportunity to explore that theory in a more practical light, in a way that I feel like really resonates with um how I want to apply that knowledge through my day-to-day life.
So, Jennifer, what do you say when families ask about our ability to set people up to get admitted into other 3-2 programs, into the second part of the 3-2 program?
We work really hard with students to ensure they're going to be a highly competitive applicant, so that they have the courses they need, they have the grades they need, they have some additional experience that really makes them look like an interesting candidate, who's passionate about this field of engineering and who knows what they're getting into and is going to succeed. And there is no guarantee that students will be accepted, but we've had really good success. I don't have any experience with a student who did not get accepted yet. So hopefully that will continue, but we just do our best with everyone.
Tell me how you work with the Center for Life Beyond Reed for students that are thinking about a dual degree program.
The way in which I have worked with CLBR is as a resource to which I refer students. So if students are interested in engineering, CLBR is a great place for them to go and they can connect students with, for example, alumni who are working in different industries for possibly an informational interview, maybe even a contact that could build into an internship or something like that.
And what I'm also hearing is if you feel like there are opportunities for students to improve or to have different experiences, you will help them understand what that looks like for them.
I do my best. Students also, it's your life, right? So you have to do a lot yourself as well. But we can give advice, we can provide resources and help you along that path.